So today we will be doing this SEMA homework problem. SEMA homework. A cylindrical tube containing water spins around an axis perpendicular to the symmetry axis tube and located at the far end of the tube going through the center of the tube's cross-section, which is conveniently depicted as this omega axis right here. So, which of the following should show the pressure in the water as a function of distance, L, from the axis of rotation? So, we have two forces, right? So, we have a centripetal force, and that force is actually going to be provided by the water pressure at that distance L, pushing left, and that's going to provide the centripetal force needed to maintain a uniform circular motion. So first we need an equation for the centripetal force. Well, we know that's m omega squared r. So let rho be the density, let A be the cross-sectional area, which we know is a circle, and omega is angular velocity. So the mass is just the density times volume, right? So if we take a volume with thickness L, for example, if we take this chunk, this volume right here, this cylinder, that is going to have a mass of rho times A times L, and then omega squared, and then the distance, in this case the radius, it's going to act on the center of mass of that chunk. So it's going to be at L over 2. Okay, so that's the centripetal force. And then the force due to the water pressure is just going to be the pressure at this point times the area of the cross-section. So as a function, we have P of L. This is not P times L, this is P of L. As a function, here, function times area. And we can set these equal. So we have P of L is equal to 1/2 rho omega squared L squared. And this is going to be a upward pointing quadratic because of the L squared. So it's D.